So this is the class definition. I have just reduced the size. Now we will pick up the functions one by one and implement them for a diagonal matrix. Then simultaneously I will show you how changes can be made for writing other matrices. So here remember that we are just looking at how the program should look like, but writing the actual code, I will write the code and show you. So let us pick up the first function, that is constructor. So constructor, for implementing it outside the class, then write the class name and the constructor name. The parameter is dimension n. This will take the dimension of a matrix n cross n, so 5 or 6, whatever the size is. As per our example, it was 5. So this 5 should be set in this one, this value should be set in that one. So the member of a class can be referred with this operator. So this arrow n, assign n. So this keyword we can use for accessing the member of a class, and this n is a parameter. So if you are aware of this, that this is a pointer to an object itself. So this we can use if there is a ambiguity in name. See, this, the local member is n and the parameter is also n. So if both the names are n, so I cannot write n assigned n. That is meaningless. So this n means the member and n means local variable. So I have taken a size. Then for that same size, I have a pointer here. So I should create an array in a heap of that size. Suppose size 5. Then I should create an array in heap. So a assign new int of size n. So I can simply take either this n or this n. So if I want to write this, then I should say this arrow n or just n. So this will create an array. This is a constructor. So inside the constructor, this is created in heap dynamically. So simultaneously I will show you the destructor also. So if I am implementing this destructor, class name, destructor name, then what a destructor should do? If a class is acquiring anything at runtime from heap, it should release that one. Or if an object is acquiring any resources, it should release the resources. So heap memory is a resource. So when we said new in the constructor, then we should say delete in destructor. Delete this a, but it is an array. So okay, mention the subscript operator for an array. This is what we need. So I have finished with constructor and destructor for a diagonal. Now I have to pick up the next function. But before picking up the next function, I will explain something about other matrices. If it is lower triangular matrix, then what will be the change? Definitely the class name and the constructor name will differ, but apart from that, what will be the change in the code? See, here we are creating an array for a diagonal matrix that is equal to size n. But in a lower triangular matrix, what will be the size of an array? The size of an array is equal to number of non-zero elements. So the non-zero elements are how many? N into n plus 1 by 2. These many elements are there. So here, if I am writing the code for lower triangular matrix, then here I should write n into n plus 1 by 2. This is the change. Now, depending on the matrix that you are writing, you have to allocate the space. So use that formula for the space. That's it. It's simple. Class name is related to the matrix and this will change. And the destructor you must write. Dimension you must take. Everything is same. Only here the formula will change. Now you get a space sufficient for storing all non-zero elements from a lower triangular or upper triangular or toplets or tridiagonal, any matrix. So you give the size required for storing all non-zero elements. So this is the size. Next, I have to implement create function. So I will pick up create function. I will remove this and implement create function. For create function, return type is void and the class name diagonal and then the function name create. So I am saying that create means reading all non-zero elements and filling them in this array. But actually it is for diagonal matrix. Yes, diagonal matrix. Suppose it is 3 cross 3. Then this will have some element here. Let us say 6 and 0, 0 and 0, 5, 0, 0, 0, 9. So only diagonal elements are there. What about rest of them? They are 0. Shall we read those also? So let us read it just like a matrix, a two-dimensional matrix, and store only those which are non-zero. Rest of them we know they are 0 only. Just ignore them, take them and ignore them. So I will write down the code for reading this entire matrix. So for that, I need two for loops. For I assign 1, I is less than equal to n, I plus plus. Why 1 onwards? See, usually in for loop we start from 0 onwards. But if you remember, the matrix indices we have taken them from 1 onwards, right? For any matrix, we have started the indices from 1 onwards. So that's the reason I am starting from 1. Then, next for loop for j assign 1, j is less than equal to n, j plus plus. Then read the value in some variable. C in, let us take it in some variable. So I need one variable here. Now, this value will be non-zero only if I and j are equal. Otherwise, it is a 0. So I should check the condition that if I is equal to j, then in a of I minus 1, see this is the formula, I minus 1, this is the formula, assign x. Otherwise, don't assign anything, that's all. So this is how I have written. See, one thing here. I am trying to take all the elements of a diagonal matrix, zeros as well as non-zeros. So I want the user of my program to feel as if he is entering entire matrix, complete matrix, all the elements. My program is deciding whether to store or not to store by checking the condition that if I is equal to j, then store the elements, otherwise don't store, just ignore it. Take the value, but don't store it because the other values are zeros. This is how I have framed the procedure. If you feel that no, we should take only non-zero elements, then just using single for loop, you can read all non-zero elements from 1 to n. You can read all the elements. So you don't need to for loop and you don't have to check the condition. Simply take only non-zero elements. So that's your choice. While writing the program, I will write the code only for reading non-zero elements and show you. But here the field is, one is entering the complete matrix. Then you will be thinking that why one should enter zeros also. Yes, that's what I am saying. If I think that I should not waste the time of the user, let us take only non-zeros. Now, with this, I can explain you other matrices easily. If this create function is for lower triangular, then everything will be same. Number will be non-zero, element will be non-zero, only if I is greater than or equal to j. So only say I greater than or equal to j, and here I should store the element where? In the formula. And what is the formula for a lower triangular matrix, row major formula? That is I into I minus 1 by 2 plus j minus 1 assign x. So I am using the formula and storing the element. This is for row major formula of lower triangular matrix. That's it. So the code is same, only the formula changed. Now this code became for lower triangular matrix, where the array size will be larger, not this one. Then change the formula, it becomes a column major. So only at some places you have to change the formula, otherwise rest of the code will be same only. Now get and set functions are simple functions just for setting the value and getting the value, similar approach. So directly while coding we will see. Now display function I will show you. So for displaying, I want to display it as a matrix only. So again, for all the elements of a matrix we need two for loops. So already I have two for loops. So let us change the name of this function as display. I will not need this variable. Then remove this one. Then two for loops. What is the purpose? Printing. So for that, I will say cout. So for a diagonal matrix, say cout a of I minus 1. When? If I is equals to j. Otherwise, if I is not equal to j, then else cout 0. Give some space also. Here also I should give some space so that space is given in between every element. That's it. Then after the first for loop, say C out and L, end of two for loops and the function call. So this code will print the matrix, and it will print complete matrix with all the elements, zeros as well as non-zeros, everything it will be displaying. Now again, instead of showing just non-zero element, I am showing zeros also, that is coming as a print on the screen. This is for diagonal matrix. Then what about lower triangular when row measure formula is used? Everything will be same. Here the condition will be I if I is greater than equal to j. The elements are non-zero. Then for printing, I have to use the formula C out A of. How to retrieve the elements? How the elements are mapped? That is I into I minus 1 by 2 plus j minus 1 and some space after the element. That's all. Now this code became a code for lower triangular matrix. So we have implemented all the function except get and set. I did not show that. So that's a simple function that storing a value and retrieving a value. We will see that while writing the code. So in the following videos, you will find the classes and the main function for all the matrices one by one. So in the following videos, I'll be showing you a complete program, a menu-driven program, which allow us to access all these options, either create or display or set the value or get the value. I will write menu-driven programs for each and every matrix. And you can see that all those programs look similar, only the formula will be changing. So I have given an overview of all the classes or the programs that I am going to show you. So that's all.